AOPS number theory 8.28. Determine the largest possible integer n such that 942 factorial is divisible by 15 to the power of n. So 15 is equal to 3 to the power of 1 times 5 to the power of 1, which means 3 to the power of 1 is divisible by 942 factorial. So is 5 to the power of n, and since they multiply up to 15, and since there are more factors of 5, the number of factors of 15 is the number of factors of 5. So 942 divided by 5 is 188, 2 over 5. We do that thing to find that there are 233 factors of 5 in 942 factorial, which means there's 233 factors of 15. So the largest value of n is 233. AOPS number theory 8.34. How many natural numbers require 3 digits when written in base 12, but require 4 digits when written in base 8? So if it requires 3 digits when written in base 12, that means 144, which is 12 squared, is less or equal to n, which is less than 12 to the power of 3, which is equal to 1728. And if it requires 4 digits when written in base 8, that means 512, which is equal to 8 to the power of 3, is less or equal to n, which is less than 8 to the power of 4, which is equal to 4096. So that if we just combine these two inequalities, that means 512 is less or equal to n, which is less than 1728. So the number of values of n is 1728 minus 512, which is 1216. AOPS number theory 8.35. Find the 100th smallest positive integer that can be written using only the digits 1, 3, and 5 in base 7. So there are 3 to the power of n positive n-digit integers that use only 1, 3, and 5 in base 7. And that's because if it's one digit, then it's 3 to the power of 1, because you can have one possibility for that digit, for one digit, and there's 3 total digits. And if there's if there are 2-digit integers, there's 3 to the power of 2, because for each digit, you can have another possibility out of the 3. So 3 n positive n-digit integers that only use 1, 3, and 5 in base 7. So 1-digit, 2-digit, 3-digit total is 3 plus 9 plus 27, which is 39, which is less than 100. So we must have a 3 to the power of 4, which means it has to be a 4-digit. And 100 minus 31 is 61. So the 61st smallest 4-digit base 7 integer using only 1, 3, and 5, because 3 to the power of 4, which is 81, is too big, so it's going to be greater than the 100ths. So 3 to the power of 3, which is 27, base 7 integers that begin with 1 and use only 1, 3, and 5, because first we want to find the smallest ones to get the 61st. So there are 27 more that begin with 3. So 39, the beginning 39, plus 27 is 93. This 27 is the ones that begin with 1, and this 27 is the ones that begin with 3, which is equal to 93 base 7 integers. So 93 is just 7 away from 100, so we just count the rest from 94 to 100. So they start with 5, so we count all this from the smallest 5-digit one to 100, which is 5151 in base 7, and we convert that to base 10, so it's 1800.